Hello everybody, welcome to lesson number 2 of the Arduino Focus workshop. My name is Jeffrey and I'll be running through this lesson today. We hope you enjoyed lesson number 1. In this lesson we'll go over what happened in lesson number 1, such as the setup and loop features, as you see on the screen right now. We'll go over some of the pre-built functions that were touched on in lesson number 1, such as digital read, digital write, pin mode, and delay. We'll explain how buttons work in Arduino, and this will be a little bit more complicated as it gets into the circuitry of what you actually need to build in real life in order to make it work. We'll then explain if-else conditions, and basically allowing something to happen if a certain situation is true. And we'll demonstrate all of this with the Arduino and WOW key as was done in lesson number 1. So first, let's recap what happened in lesson number 1, and that is going over the setup and loop. So, as you know in Arduino, as soon as you open up something in the Arduino IDE, you will be given these two things that are pre-written for you, right? And what this does is, as was said in lesson number 1, void setup will run once. So any of the code that you put in between these two curly brackets right here, it will only run once. And this is very useful. Let me just clean up my handwriting here. This is very useful for you if you want to initialize your pins, or if you want to have a startup sequence, right? It won't run infinitely. It'll just run once, and then it'll move on to the loop. And the loop will run infinitely. Oops, my bad. The loop will run infinitely. And this is the code that you want to be executed over and over and over again. So if you had an alarm system, for example, you'll put the code to actually make the alarm work in the loop. Whereas to set up the alarm, to initialize all the pins in the Arduino, you put that in the setup. Again, any of the code that you put in between these two curly brackets will run infinitely. Now, just to illustrate this with a block diagram, imagine that we start off with the play button. Once you press play, the program will execute. So the play button is actually quite important here. All right. And if we imagine all the code in between the two curly brackets for setup as one big block, we'll just pretend it's one big block. Setup. Alright, so as soon as you hit play, the program will run through the setup code. And once it's done running through the setup, it will run through the loop code. Imagine if it's one big block, again, as we've done in the setup, between these two curly brackets, and this one will run infinitely. So cycle over and over and over again until you press stop. Alright, now we'll talk about some of the functions that we'll be using in our programs. But before we do that, let's talk about variables. Alright, so there are two main types of variables that we'll focus on. We'll call them integers, and this is basically a whole number that is either positive or negative. We'll shorthand that to int. There are limits to the size of this number in the Arduino. We probably won't be getting there, but for all intents and purposes, this is a whole number that we can use. The next type is called a Boolean, or we'll shorthand that to bool. And in computer science, you may know this as true or false, but in the Arduino, these are actually called high or low. And high is 5 volts and low is 0 volts. And these are important because we call these logic levels, logic voltage levels. And they are used in a whole wide array of components. And the Arduino is able to read whether something is 5 volts or 0 volts and call that high or low. So going back to the functions now, pin mode, as the name implies, sets the mode of the pin, and it's either input or output. So sets pins in either input or output mode. So it's either reading the logic levels or it's outputting a logic level, so 5 volts or 0 volts. Digital write, as the name implies, again, we're going to write voltages to a certain pin. So we're going to set a pin to either 5 volts or 0 volts. Pin to either 5 volts or 0 volts. All right, and the way that the syntax works for this is digital write, so pin number, and high or low, so basically the Boolean that we talked about earlier. An example of this would be setting setting pin 13 high. So that all we have to do is write 13 and then high. All right. The next function that we have is digital read, and this essentially allows us to put in the whether a pin is high or low into a variable. All right. So before we talk about that, let's talk about how to declare variables. Going back to our two types that we'll be using in our program, we have int and we have bool. To declare a variable, all we have to do is put in the type, then we'll put in the name of the variable that we want. So if it's an integer, we'll just say num, shorthand for number, and then we'll put a semicolon. All right. If we want to attach a value to that, we can write int num equals 3, for example, and then semicolon to close it off. Same thing with bool. We have bool state equals high. And as we go along throughout these the program, we can change the value of these variables. If you already declared it by putting a type right here, we can simply write num equals 4 at some later point in the program. It's important to declare the type at the beginning as soon as you want the variable to exist. You don't have to declare it for future instances where you're changing the value of the variable, such as in this line right here. All right, so going back to digital read, this sets a variable, a Boolean variable, I should say. It has to be a Boolean, I believe. It might be able to be a num, but it will set it to 0 or 1, but that's something that you have to read in the documentation. So set a bool to either high or low based on a value of a pin. Based on value of pin. So an example of this would be, let's say we have bool state, and then we do state equals digital read, and we're going to read pin 13. There we go. And just write that better. Now it's important that if we use digital read, that we initially set the pin mode of pin 13 to input. All right, we can't read the pin that is set to output. And finally, our last function is delay, and this basically sets a delay in the program for a certain number of milliseconds. So, for example, if we want a delay of 1 second, we would write this as delay 1000 semicolon. And this function is useful because oftentimes in the program we just want it to do nothing, just execute, just sit there and wait for something, or continue the previous function that it was doing before, just giving it time essentially to compute. All right, let's move on to an example. All right, so now that we're in WowKey, let's set up our circuit with an LED, and let's just have it blink. And this is an example that you probably covered in lesson number 1, so I'm trying to go through it quickly. We'll get our LED out. We'll get a wire connected to ground and a wire connected to pin 13. This is actually a very nice placement of an LED in real life. You don't actually need wires in real life. You can just stick the LED in those two sockets and you'll have a functional circuit. So this is why we designed it with pin 13. Alright, so in our setup, we're going to initialize pin mode. So pin mode, and we want pin 13 to be an output. Oh look, this IDE gives us the type, the name of the variable that we can put into it for us, so that it makes it easier for us to code. So we're going to have it blink once, so we're going to write digital write. So this is setting pin 13 to a high state. So we'll set it to high. All right. Then we're going to delay. We're going to delay for 1,000 milliseconds or 1 second. All right. Then we're going to write it back to low. And this is something that's important for you all to remember, that once we set something high, it will stay high until we write it low again. It won't automatically go back to low after a certain amount of time. So it's always important to remember that we gotta bring pins back to low when we don't want them to be high anymore. And that sounds obvious as I'm saying it, but I assure you that when we're programming something later, you might forget it. It's something that's easily forgettable. So let's run this. As you can see, it's on, then it's off. Quite simple. But let's try something a little bit more complicated now. Let's put it inside the loop. Alright. So now we want it flashing for forever, essentially, with a 1 second delay between on and off states. So how do we do that? Well, just like as we did with just the flashing once, we'll write digital write, pin 13, we'll set it to high. We're then going to delay it, so it's going to leave it in that state for 1 second or 1,000 milliseconds. And then we're going to set it to digital read or digital write, pin 13, and we're going to set it to low. So this turns it off. So just to recap how the logic of this function works, we're going to set it high in this line. We're going to wait 1 second, and then we're going to set it to low. Now, we need another delay here. And the reason being is, as soon as we hit this semicolon that I'm highlighting in line 12, it will jump right back up to line 8, and it will start executing all over again. So if we didn't have this line, it will turn off, and then it'll turn on basically immediately, and we can't see it. So let's run this. And as you can see, it's now blinking forever. In fact, if I leave this on running, I don't want to create a 2-hour-long video for you just of this LED blinking, so I won't do that. But it will run forever. Alright, let's talk about buttons now. Let's first draw our push button. And this is a button that, well, as you imagine, is like a button on your keyboard. You push it and it springs back up. So you must hold it down for it to remain closed, and we'll talk about what that means in a second. So a button really is similar to a switch of sorts. And this is the electrical drawings for a switch. This one is open, and this one is closed. Closed means electricity can flow. And open means electricity can't flow. Can't flow. So for a push button, the default state, if you don't touch it at all, default, it's open. So if you don't push it, then it won't transmit any electricity. But if you do push it, it will be closed. Now, push buttons in real life and in the Arduino simulation in Wowkey, they have 4 legs. 1, 2, 3, 4. Wait, this doesn't make any sense. A switch only has 2 terminals, right? So how does this work? Well, the way that they designed it, and this is for simplicity, this is for practicality. To put it in a breadboard, it's nice and easy if you have 4 legs, makes it nice and stable. But how it works electrically is that these two are basically connected. I should actually use a different color. Let's use blue. These are connected electrically, and these are connected electrically. And the switch, whether it's open or closed, is between these two lines. So in this case, the switch here is closed, and if you push it, so it will be closed. Electricity from here can go out here. So what we want to do essentially is that whenever we have a push button like this, we want to connect it diagonally. All right. So I can either be from here, just fill that in with red, to here, or let's choose a different color. Let's choose green. Here to here. If you connect red with green, you'll get a short circuit. And that's not what you want, unless you know what you're doing. But in any case, you want to connect red to red or green to green with push buttons. Well, that's all well and good, but how do you make a circuit for that in Arduino? You can't just attach a push button into the sockets for an Arduino and expect it to work. That's not how this works. What we need to do is we need to create something that's called a pull-up network using a pull-up resistor. Pull-up resistor. And you can actually Google this. There's a wiki page on it for all of you who love to read wiki pages. At the same time, there's something that's also called the pull-down resistor. We're just going to be using the pull-up resistor for now. Seems to work better in Wowkey, and they follow the same theories. So we use this. All right. So how it works is that what a button needs to do is essentially change the value of a pin from 5 volts to 0 volts. All right, and we'll use a resistor to help out with this. But where do we get the 5 volts from? We obviously need a voltage source. So this will be our voltage source. This is 5 volts. All right, so 5 volts is coming out of here and going down this wire. We will put a resistor right here. Typically about 10K for a pull-up resistor, for a pull-up resistor or a pull-down resistor. So 10K ohms. But in general, you can choose anywhere from 2 to 10K. 2K to 10K. Yes. We need a large resistor because we don't actually want a lot of current flowing through it. We just want the voltage to pass through. All right. So we're gonna add our resistor right there. We're gonna put our switch here. All right. We're gonna put this to ground. So we're gonna ground it, and then we're going to attach this wire. Let me just draw that a little bit better. We're going to put this wire and we're going to have it lead, goes to Arduino. Goes to Arduino. Okay. So let's analyze how this works. Well, if this switch is open, right, that means no current is able to flow through to ground. And no current can flow through here. Let me just change that to red just to visualize it better. Current can't go through here, and it can't go through here. Current doesn't like to go into the Arduino. Alright? So what happens is, since it's a closed circuit, the current can't go anywhere. At this point, right here, let me just use a different symbol to illustrate it. At this point right here, we get 5 volts. Right? Current can't go anywhere. The capacitor acts as basically a wire. It doesn't do anything because the current's not flowing through. So the whole thing is 5 volts. Alright? Now what happens if this is closed? Let's erase all of this. Alright, let's redraw the switch and let's have it in the closed position. Alright, now the current can flow through and it goes to ground. So all the electricity from the 5 volts goes to the resistor and goes to ground. So what is the voltage at this point? Question mark? Well, a resistor is in the way. So and by analysis, it's the only thing on this circuit with resistance. So it's going to use all 5 volts. So at this point, it's actually 0. 0 volts. 0 volts. Alright, and 0 volts is also being read by the Arduino pin. So it's 0 volts. And this is how we get our high and low states. So let's just draw a table to illustrate what happens. Alright, so switch and voltage to Arduino. Alright, so when the switch is open, that means no electricity is flowing through. We have 5 volts to the Arduino, or high. If the switch is closed, we get 0 volts to the Arduino, or low. Perfect! We can use this in a circuit, and I'm going to demonstrate it to you in the next example. Alright, so before we use the button in an actual example, we need to talk about if statements, which allow us to execute a certain piece of code to do something specific if a certain situation is true. So the first part of an if statement is the if brackets. And this is the first situation that we will test, whether it's true or not. We test and execute if true. Alright, we then have our else if situation, which is the second situation we test if the first situation turns out to be false. And we execute if that's true. And finally, we have our else part, which happens if all other situations are false. Happens if all other situations are false. Now, when we have an if statement, we obviously must have this. We must have our if brackets, and in here we will put logic statement. And what the logic statement is essentially is the situation that we are seeing if it is true. So if some variable is true, for example. All right, we have our, and this is mandatory. So we must have the if section. We actually don't need to have that else if we don't need it, or we can actually have as many of these as we would need. So it depends whether you need to test the second situation, the third situation, or fourth situation. It depends on the logic of your code, whether you need multiple else ifs or if you don't need them at all. And finally, we have our else. Again, this is actually not mandatory if all you need is an if. It just depends on the logic of your code. So it's quite modular, the if statement, whether we add more or less. It all depends on the logic. So let's talk about the logic statement. All right. So in a logic statement, it tests if something is true. All right. So let's say we want to test if a certain variable is equal to a number that we have in mind. So for example, if we have int num equals 3, we can test if in our if statement, if num is equal to 4, right? In this case, it is not equal to 4. So once we test this, it will find out, nope, this is not true, and we'll just skip it. And if there's an else statement here, it will execute. So else, and then it will start executing this. All right. So we see if something is true with something that's called an operator here. That's the double equal sign that I put here. And there's a whole list of operators that we can choose from. Double equal, test if something is equal. Exclamation mark equal sign. Test something if it is not equal. Greater than, less than, greater than, equal to, or less than, equal to. These are all different operators that we can use to test situations. All right. One relevant thing that we will have to do with our booleans for our buttons is we're going to have a boolean. We'll call it bool state. All right. And in our if statement, we are going to need to test if state equals high or low. And this will tell us if the button is pressed. And we'll use this in example coming up now. All right, so we're going to go through an example where if we push down a button, an LED will turn on. If we release the button, the LED will turn off. So let's get all our components onto the simulation board to our right. So we're going to need a resistor. We're going to need a push button as well to build our pull-up resistor. So let's wire these two things first. Well, first things first, we got to change the resistance of this. And to do that, we're going to go into diagram.json. We're going to find the resistor right here. And we're going to change it to 10,000. And this represents 10,000 ohms. For the button here, we're going to have to turn off bounce. The reason being is something called debouncing, which you can actually Google. We don't have time to get into that right now, but essentially the Cole's notes of it is that sometimes the button, the physical button, doesn't make good electrical contact with the pins, and this will cause rapid on and off motion that the Arduino is fast enough to pick up, which turns into rapid on and off for our code. and that's not what we want. But in any case, we're just going to wire up our pull-up resistor now. We're going to wire to the button like this. We're going to remember that the connection for a push button with 4 pins is diagonal. We're going to wire this back to ground, and then we're going to attach a wire from the button all the way into pin 0 so that we can read what value the button is. Alright, now we're going to wire up this LED. Remember that this pin goes to ground, this pin goes to pin 13. Perfect. Now we can get coding. First things first, we're going to remember to initialize all our pins. So pin mode 13 is input, or sorry, it's output. This one goes to the LED. Don't forget our semicolon. Pin mode 0, that is the one that's connected to the button. It will be an input. Alright, and in our loop, we're going to have to remember that when the button is held down, pin 0 reads low. So in our if statement, we're going to have to remember that. But before we get to our if statement, we need a variable. We need a boolean. So bool state. And we're going to set this equal to digital read. So as soon as the loop runs, it will read pin 0. It will put it in a newly initialized variable called state, which will either be high or low. And let's not forget our semicolon. Now we get to the if statement. So if, now we need a logic statement. So if state equals, which is asking if the state is equal to something, and in this case we're going to set it to high. So if it's high, what does this mean? Well, it means that the button is not pressed. Alright, it's not pressed when state equals high. Alright, so that means we're going to have to write into pin 13 low, because we want it off. Now, else, because there's only 2 possible states a button can be, so if it's not high, then it's low, which means the button is pressed, which means we want the LED on. Alright? So we're going to have to write digital write, pin 13, high. There we go. And this is it. This should work. Whenever we hold down the button, the LED will be on, and whenever we let go of the button, the LED will be off. Perfect. Well, this wraps up lesson number 2. Thank you for sticking around, and thank you for attending this lesson. We have 2 practice problems for you, one simple and one challenging. And on my screen right now is the simple problem. In this problem, you're going to be toggling an LED with a button. So if you press a button once and then let go, it will turn on. Press the button again and let go, the LED will turn off. And a hint for this is that you need another variable, another boolean, to store whether the current state of the LED is. So whether the LED is currently on or whether the LED is currently off. All right. For the challenge problem, which I will just pull up here. For the challenge problem, you have a rainbow. All right, you have a rainbow. And for this one, again, similar to the first one, when you have a button, you're going to press it once, it will turn on the next LED. Press it again, turn on the next. Press it again, turn on the next, and so forth. Once you get to the purple, if you press it one more time, it will go back to the red. Or if you can have it in the other direction if you want. If you have it going from left to right, as soon as it gets to the red, it will go back to the purple LED. And again, similar to the first one, you're going to need a variable, or maybe a couple if necessary, to store the current values of the LEDs. So which one is currently on? Alright, and that wraps it up. If you have any questions, feel free to reach out to us on our Discord channel, and we'll be there to answer any questions that you have. And we hope to see you again in lesson number 3 and beyond.